Good afternoon, ladies and gentlemen. This is Professor David J. Rodriguez. I am here in Los Angeles right now. Okay, hold on. My topic this evening will be a solution of the second type of differential equation, homogeneous differential equation. Okay, this will now be my second example on homogeneous differential equation. Okay, let's proceed. This is now my lesson number 17 on my channel, Professor David J. De Los Reyes, on the course differential equation. The topic is homogeneous. This is number 2. The previous discussion was lesson number 1. It is still a homogeneous. I will give you some more examples of homogeneous differential equation. It's another variation of a problem. So this is actually lesson number 17 under the course differential equation. Okay, I will try to read the problem. The given differential equation is 3x squared y dx minus open quantity 2x cubed minus y cubed closed quantity dy equal to 0. Let's check if this differential equation is homogeneous. The degree on the dx term, this is 2 plus 1, it is 3. On this term here, it will be 3 plus 0 and it will still be 3. On this term, okay, it will be, for x it will be 0 and for y it is 3, so 3. So as we could see, the degree of all the terms, if we try to expand, it's all 3. So we could say that the given differential equation is homogeneous differential equation. Okay, that's the definition of a homogeneous differential equation. Because just in case this is a square, it will not fall under homogeneous because it's the counting of the degree will be 3, 3, and 2. And the condition for it to be homogeneous, the degree of all the terms, if we try to expand, will be the same. So if this is 3, this should be 3, and this should be 3. This is 2 plus 1, it's 3. This is 3 plus 0, it's 3. And this is 0 plus 3, and this is 3. So the degree of all the terms is actually 3, and we could say that the differential equation is homogeneous. Okay, let's try to bring out the solution. There are only 2 types of solution. This is the first solution. And if you try to reverse this one, that will be another solution, but it might be a complicated one. So it depends on what you choose. If you choose the solution and it come out that the solution will be easy, you're lucky. Okay, let's proceed with the solution. Solution. We will let x equal to by. Because the other substitution is actually y is equal to bx. But this afternoon or this evening, I will choose x equal to by. There's nothing wrong with it. Okay. Y is equal to, or x is equal to by. That is the needed substitution for homogeneous differential equation. Taking the differential of both sides, dx equal to, the right hand side, it is represented as a product, so it will be the first one times the differential of the second plus the second y times the differential of the first. Substituting the value of, is it x? Yeah, x and dx back here. Okay, what will come out? We will follow this. This will be 3. X will be by quantity squared. I am following this. Times y. Times y. Times dx. dx in terms of b is actually b dy plus y db. Okay? Minus. Oh, I expanded this one already. Because this was with an open quantity, but this is presented by negative sign. So negative 1 times 2x cubed will be negative 2x cubed, so this should be negative 2. And what is x? It is by cubed times dy. Okay? Negative, negative, it should be plus y cubed dy equal to 0. This is just pure algebra. This will be 3b square y cubed, open quantity b dy plus y db. I just square this one, then try to compress it. We will multiply this by this. Minus expanding this should be loss of exponent, guys. We expand this one, so it will be negative 2b cubed y cubed dy plus y cubed dy equal to 0. Then try to combine similar terms. But before we try to combine, expand first. So this will be 3b cubed y cubed dy plus 3b square y to the power db minus 2b cubed y cubed dy plus y cubed dy equal to 0. We are just lucky. This term here is similar to this. Right? So this is 3 minus 2. This will now be b cubed y cubed dy. Okay? I will rewrite this one first, plus y cubed dy. Because I want this one to be near this dy here. Equal to this one. But this one, if we try to transpose to the left, it will become negative 3b square b square y to the fourth db. Okay? I think there is a common factor y cube. Okay? So we will remove y cube here. We will remove y cube here. And we will remove one y cube over here. So this will just be simply y now. Okay? So what will come out? This should be b cubed plus 1. I compress this one. This is b cubed. This is dy dy. Okay? The common factor is dy. So it will be b cubed plus 1 close quantity dy equal to negative 3b square. Only y will remain here. Should be y db. Separating the variable. Sorry for that one. dy over y equal to negative 3b square db over b cubed plus 1. If you try to cross multiply this one, what comes out is this one. Okay, so we separate the variables now. This is a pure b function, this is a pure y function. Okay, let's proceed with the integration. To bring out the solution after the separation of the variables, okay, we will integrate. Because the significance of the substitution is that after the substitution, whether we like it or not, the variable will be separated. So actually, we are now separated the variables. So we will proceed with the integration. The integral of dy over y equal to the integral of negative 3b square db over b cubed plus 1. I just rewrite this one. I put the integral sign. Okay. Right? Luckily, for both the left and right, it falls under the natural logarithm. The value of u on the left hand side is y, du will be dy, it is exact. du is dy, u is y, so it is exact. On the right hand side, the value of u, we assume for the meantime that, because it seems it is under the natural logarithm. The value of u on the right hand side will be b cubed plus 1. Taking the differential, du will be 3b square, power formula, plus 0. Or du will be 3b square db. It is not exact. Why not exact? We got the negative sign over here. So for it to be exact, proceeding now with the integration, the integral of dy over y equal to, for it to be exact, we remove that negative sign over there. We can bring it out. Because it seems actually we got a negative 1 over here. Right? So for it to be exact, we will remove that one. we bring it out. So what will come out will be the integral of 3b squared dv over bq plus 1. And this now falls under the integral of du over u. And the answer is actually the natural logarithm of u. Right? So left hand side, natural logarithm of y equal to natural logarithm of bq plus 1, but this is preceded by negative sign because we got a negative 1 over here. Plus, we can see this one as q1. Okay? But we could place the natural logarithm sign. There's nothing wrong with it. Because if c is constant, and if we take the natural logarithm, it's still a constant, and we could see that one as simply q1. But I don't want to name it q1. I just simply put it as natural logarithm of c. Then combining similar terms, this is negative, right? We put it on the left. Then we apply the laws of logarithm. The natural logarithm of ab is actually the natural logarithm of a plus the natural logarithm of b. Because if we try to transpose this one on the right, it will be something like this. But we could compress it as simply the natural logarithm of the product of y times bq plus 1 equal to the natural logarithm of c. We will try to eliminate the natural logarithm sign. So we will try to raise both sides of the equation by e. Meaning we will take the antilog. Okay? E raised to the natural logarithm of the product equal to e raised to the natural logarithm of c. Okay? If we try to take the antilog of the logarithm, this will cancel out. Okay? So what comes out now is y times b cubed plus 1 equal to c. This is not yet our final answer because we got a b here. But from our substitution, b is actually equal to x over y. So replacing all b by the ratio x over y, what will come out will be y. This will be x cubed over y cubed plus 1 plus quantity equal to c. We try to simplify the y inside. The inside term will be x cubed, y cubed times 1 is y cubed, all over y cubed, plus quantity equal to c. 1y cancels, so what remains on the bottom will be y squared. And if we try to multiply all the terms by y squared, the left hand side, this term here cancels with this. What remains is x cubed plus y cubed. Right hand side, it will be c times y squared. So this is c times y squared. So the final answer is actually x cubed plus y cubed is equal to c y squared. This is a general solution. Because for the meantime, we do not know the value of c. There are no given initial conditions for us to solve for the constant c of integration. So our final answer, we will just leave it as simply the general solution, that is x cubed plus y cubed is equal to cy squared. So the solution of this differential equation is actually x cubed plus y cubed equal to cy squared. That's it, guys. That is our second example for a homogeneous differential equation. We tried the substitution x equal to py. And luckily, after the substitution, we are just lucky for both the left hand side and the right hand side, we could integrate it easily. Because just in case you choose x, you choose y equal to vx, and it become complicated, that's your problem. So actually in the solution under the homogeneous, okay, you are lucky if what you choose will be the easier solution. Okay, good afternoon, Los Angeles.